We're going to solve miscellaneous exercise on chapter 1 sets of CBSE class 11 maths. The first question is, decide among the following sets which sets are subsets of one and another. Let us first solve the equation given in the set A so that we can find the value of set A. Let us now write the sets. As we can see here, the 2, 6 are included in B. So A is a subset of B. 2, 6 are also included in C. So A is a subset of C. 2, 4, 6 are included in set C. So B is a subset of C. We can see that D is a singleton set 6. So D is a subset of A. D is also a subset of B. And D is also a subset of C. Moving on to the second question, in each of the following determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. If X belongs to A and A belongs to B, that means then X belongs to B. So this is false. If A is a subset of B and B belongs to C, we can write A as and B as. B belongs to C. Then A belongs to C. This is also false. If A is a subset of B, that means every element of A is in B. And B is a subset of C. That means every element of B is in C. Then A is a subset of C. That means every element of A is in C. That is correct. So this is true. Moving on to the fourth part. If A is not a subset of B and B is not a subset of C, then A is not a subset of C. We have taken let A as equal to 1, 2, 3. B we have taken as 4, 5, 6. And C, as you can notice here, that it can be from A. So we have taken 1, 2, 3, 4. and it is asking for, then A is not a subset of C. But as we have taken an example here that it can be a subset of C, so this is false. Moving on to the fifth part, if X belongs to A and A is not a subset of B, that means every element of A is not in B. So we can write B as Y. Then X belongs to B. This is false, as we can see from this. Moving on to the sixth part, if A is a subset of B and X does not belong to B, then X does not belong to A. Let A is equal to Y. A is a subset of B, that means every element of A is in B. So we have taken Y here in A, so Y is in B also. Then X does not belong to A. This is true. Moving on to question 3, let A, B and C be the sets such that A union B equal to A union C. And A intersection B equal to A intersection C. Show that B equal to C. For showing that B equal to C, we need to prove that B is a subset of C and C is a subset of B. Let X belongs to B. Then we can say that X belongs to A union B. Also we can say that X belongs to A union C. By the definition of union, we can say that X belongs to A or X belongs to C. Now we know that A intersection B is equal to A intersection C. So if we take this case, X belongs to A, we can say that X belongs to C. That means X belongs to B implies that X belongs to C. Hence we can write B is a subset of C. If we take this case, X belongs to C, we know that B intersection A is equal to A intersection C. So we can write here that X belongs to C, X belongs to B. So X belongs to C implies that X belongs to B. That means C is a subset of B. Hence B equal to C.